My problem says find the definite integral from 0 to 3 of 2x plus 1 over x plus 3 dx. Okay, well, to do that, I'm going to need to know an antiderivative of that thing in the middle. And it's not something that looks obvious to me. If that 2x wasn't there, it'd just be a 1 over x plus 3, and I'd know how to integrate that using ln. So I might be able to do a trick where I can write the top more in terms of the x plus 3 so that it'll cancel out, and I'll get something with a something over x plus 3 that'll be a little easier to figure out. But I've just noticed there's actually a problem here. This function isn't actually defined when x is -3. And if my zone that I'm integrating across contains that discontinuity, I'm not going to be able to figure out the definite integral because the area won't make sense because the function's not even defined there. So -3 is where it's undefined, and I'm going from 0 to 3, which doesn't include the -3. Okay, so I'm safe. All right, cool. So it's worth even trying. If this had included the -3, I would have said that doesn't exist. Okay, so 2x plus 1 over x plus 3. Well, that if I had 2 times x plus 3, that'd give me the 2x, and 2 times x plus 3 would be 2x plus 6. So if I arrange there to be a 6 on the top by putting a +6 and a -6, then I haven't actually changed what this function is because I've really added 0. But I've created something that can be written with an x plus 3. So 2x plus 6 is 2 times x plus 3, and -6 plus 1 is -5. And then now division can be done each part separately when there's just a single thing on the bottom. So 2x plus 3 divided by x plus 3 is just 2, and 5 divided by x plus 3 is that. And now I reckon I can do it. I know how to integrate 2. And if I wrote this as a 1 over, then it's easier for me to see that I can use ln. And it's just a linear thing inside, and I know how to deal with that. Okay, so I can do it now. The integral from 0 to 3 of 2x plus 1 over x plus 3 dx is the same as 2 minus 5 times 1 over x plus 3 dx. And then let's see. The 2 would become a 2x. The 5 is multiplied on, so it'll still be there afterwards. And then this would become ln of the absolute value of the x plus 3. And because this is linear, we're even allowed to do this trick. All we have to do is divide by the constant that's multiplied by the x, but that constant's 1, so that's not going to change it. Cool. So now I have to sub in the 5 and the, not 5, sorry, the 3 and the 0 and see what happens. So let's see. 2 times 3 minus 5 times ln of 3 plus 3 is 6, minus 2 times 0 minus 5 times ln of 0 plus 3 is 3. Okay, cool. And that would be 6 minus 5 ln 6, because 6 is positive anyway. The absolute value is not going to make a difference. Minus, that's 0, minus 5 ln 3. Okay. I could figure it out now, but I reckon I can make it even simpler and get a nice exact mathematical answer first, which is always pleasant. So let's see, that's 6 minus 5 ln 6 plus 5 ln 3. I know that subtraction with ln's has a rule. I'm going to pull out a 5 because they've both got a 5. Okay, just a second. No, that's not a plus. That's supposed to be a minus. So I've removed the -5 here. If I remove a -5 here, I'm going to have to leave a minus behind or it won't turn out the same. Let me just check. -5 times ln6 is -5 ln6. -5 times minus ln3 will be plus ln3. Okay, so I've factorized it correctly. And logs, subtraction outside is the same as division inside. So that'll be ln of 6 divided by 3. So I've got 6 minus 5 ln 2. All right, and I think that's as simple as it's going to get for the exact answer. And let me get my calculator and figure out what that is. 6 minus 5 times ln of 2 is approximately 2.5343 to 4 decimal places. Let me just check that I've done my algebra right. If it's the same answer up here as it is down here, then I've done that correctly. So let's see. Brackets 6 minus 5 times ln of 6. That's this bit here, minus 5 times ln of 3. Oh, did something wrong. 6 minus 5 times ln of 6 minus 5 times ln of 3. Cool, same answer. Right, I reckon I've done it right.